Okay, here's another solution for a statics problem. Okay, in this case we're taking problem 12.43, like your homework problem, and I'm changing the number. Instead of a 1,200 pound weight at the end of this beam, I'm making it 1,500 pound force. Okay, so here's the setup. We have this cable, we have a pin at point A, we have a weight hanging down from point B. The assumption is that the beam has negligible weight with respect to the weight on the end of the beam. Okay, so what we're asking for here is the tension in the cable and the reactionary forces at A. Alright, so the usual steps. First, make a free body diagram. Okay, so I've done that. I put the dimensions on there. I've separated out the beam, and at this point what we need to do is add the forces. Okay, I'd already added the force W, but we know that we have a reactionary force AY at the pin for A, and since it's a pin, there's also a reactionary force in the X direction. Okay. Alright, so we're trying to solve for T, AX, and AY. Alright, so I know the approach on this problem, and so do you. You've worked some of these. And so you start thinking about what are you going to need. Alright, and so I'm looking at this tension T, and I know I'm going to need to resolve that into components so that I can calculate some of the forces in the X, some of the forces in the Y. So I get started with looking at some trig here to try to figure out what I'm going to need. So let's change the color here. Let's make this green, and I think, if we knew this green triangle, that would help us out, because if we knew this green length, we would know this length. Okay, and if we know this length, we would be able to calculate this length. Okay, so let's put some letters on here, some variable names. Let's call this A, let's call this B, let's call this Y. Alright, and what I know is that this length here is 6. Alright, so looking at the trig that we need to do here, here's the trig. We know that B is going to be the sine of the angle, 35 degrees, times 6. Alright, and then A is cosine 35 degrees times 6. Alright, so that's just properties of triangles. Alright, and once we know that Y is going to be, this length is B, so the total length is 8, so Y is 8 minus B. Alright, and then I remember my goal was to resolve T into components. So if I knew this angle alpha, and I can find that, alpha is going to be an arctan of Y over A. This length A is the same here. Alright, so at this point I know all these numbers. Alright, so I can plug those into my computer or my calculator, solve for B, solve for A, solve for Y. Everything's known at this point. I know all the quantities in yellow. Alright, so that lets me move on. Okay, so the next step is sum of forces in the X direction. Okay, where moving to the right is positive. Alright, so I see an AX, and the only other component working in the X direction is the TX. Alright, so that would be T cosine alpha. So there's an equation. One equation, two unknowns. Alright, so we need more equations. So we need sum of forces in the Y direction. Okay, so looking at the free body diagram, I see I have AY moving up, I have the vertical component of t. That's also moving up, so this would be plus t sine of excuse me, t sine of alpha. All right, and then I have the weight moving down. Okay, so that'd be minus w equals 0. So there's a second equation. All right, w is known. All right, t is unknown, alpha is known, but ay is also not known. So at this point we have 2 equations but 3 unknowns. So we still need another equation. So let's do the sum of moments about point A where counterclockwise is positive. All right. So looking at that, I can resolve t into components. So let me use a different color here. I'll use purple. All right. So t has a vertical component and a horizontal component. Okay. So if I want the moment generated by the horizontal component from point A, then what I need is the perpendicular distance to the force. Right? It doesn't matter what the line of action is. I can extend this on out. I just need this perpendicular distance. Well, what is that perpendicular distance? I look at the diagram, it's B. All right, so there's a rotation moment generated, B, times T cosine, because that's the horizontal component, cosine of alpha. All right. Now let's look at the vertical component. So the vertical component, that's moving up this way. I need the perpendicular distance to A. Okay, so I can extend this down and look at this. That distance would be A. Okay, plus A times T, and the perpendicular or the vertical component of T is T sine alpha. All right. Okay, and then finally we look at the moment generated by W. So W is already in a vertical direction, so I can extend that down and find the perpendicular distance. Okay, so that would be, we don't know that. We have to calculate that. But I do know the total length of the beam, and I know this angle. So this length, I'll change the color again, this length in pink. This length in pink is 8 times cosine of 35. All right, so that moment would be, back to purple, plus 8 cosine 35 degrees, that's the perpendicular distance, times W. All right, now I should take note of which direction that's causing the rotation. That causes the rotation in a clockwise direction, so that means the sign on this would actually be negative. Okay, so those are the equations. You set that equal to 0. That's my third equation. Okay, so 3 equations, 3 unknowns. You should be able to solve for everything that you need. Okay, so I did that, and the numbers I get are that AX is 1,229 pound force. AY is 2,640 pound force, and T is 1,600 and 1660. Okay, so that's the solution to this problem. Yeah, I think this would be an exam problem that you could do. I probably would ask you to just set up the equations in this particular kind of problem, and so solving them, I realize that takes some time. I'm going to assume that well, I'll test you on, have to be able to solve some problems on the, or some systems of equations on the exam, but generally I'm more interested on whether you can write the equations.